Welcome my dear students, welcome to my channel physics module. First of all I am going to say that I am very much sorry because 2-3 हफ्ते से मेरे चैनल में कोई वीडियो नहीं आ पाया, मैं शूट नहीं कर पाया था, मेरे कुछ पर्सनल प्रॉब्लम्स आ गए थे. But here I am once again with my videos and I am promising you that this time it's gonna be a pretty much regular case. Okay, so let's start. The topic with which I have come today is basically an ICSE topic. It is common for all the other boards, which is heat and energy. In this video there will be a detailed discussions regarding heat, temperature and the terms related to quantity of heat, calorimetry, heat transfer, thermal expansion. So stay tuned till the video ends. There will be a lot of knowledge to be known for you guys. There is a first and foremost thing that we have to know about heat is a form of energy. Okay, heat is a form of energy. Heat को एक एनर्जी का फॉर्म भी माना जाता है. एंड हाउ कैन इट बी कॉल्ड एनर्जी? एनर्जी उसी को बोला जाएगा जो खुद एक दूसरे एनर्जी से पैदा होता है. ओके, हीट से क्या होता है कि अगर हम ऐसे हैंड को रब करते हैं, सो ये एक मैकेनिकल एनर्जी है. सो मैकेनिकल एनर्जी यहाँ पे हीट एनर्जी में कन्वर्ट हो रहा है, हीट एनर्जी पैदा कर रहा है. दूसरी जगहों पे जहाँ पे देखो लाइट जल रहा है, बल्ब जल रहे हैं, उससे क्या होता है कि बल्ब का जो फिलामेंट है उसमें इलेक्ट्रिक करंट जाता है. इलेक्ट्रिक करंट इज अ फॉर्म ऑफ एनर्जी and from there light energy and heat energy is produced. So we can see that there are a lot of examples which can prove that heat is created or can be made from another form of energy. So hence heat can also be called as a form of energy. Okay, so if we try to define what heat is, उसको हम कैसे बोल सकते हैं कि heat एक energy है. Heat is a form of energy which makes us feel hotness or coolness. Okay, let me repeat it once again. Heat is an energy which makes us feel hotness and coolness. यानी कि कोई भी चीज गर्म है या फिर ठंडा है वो समझने में हमको हेल्प करता है क्या? हीट. और रादर किसी दूसरे एंगल से कहें तो हीट की वजह से ही हम समझ पाते हैं कि कोई चीज गर्म है या फिर ठंडा है. ओके, देयर इज वन अनदर टर्म विच कम्स अलोंग हीट which is temperature, यानी कि तापमात्रा या फिर तापमान. सो तापमान क्या है या फिर टेम्परेचर क्या है कि इट इज द मेजर ऑफ हॉटनेस एंड कूलनेस. कितना है हॉटनेस, कितना है. हीट से क्या पता चल रहा था कि हॉट ये है या फिर ये कूल है, लेकिन टेम्परेचर हमको बोलेगा कि ये कितना हॉट है और कितना कूल है. द अमाउंट ऑफ द डिग्री ऑफ हॉटनेस एंड कूलनेस इज मेजर्ड बाय टेम्परेचर. ओके, सो यहां पे क्विकली एक हीट और टेम्परेचर का एक कंपैरिजन जान लेते हैं. ओके, लेट अस सी हीट वर्सेस टेम्परेचर. अगर हम एक टेबल बनाएं उसमें क्या क्या लिख सकते हैं हम? पहला तो एक पॉइंट है, हीट जो है वो सेंस करता है हॉटनेस और कूलनेस. ओके, टेम्परेचर में मैंने क्या बोला था? इट इज द मेजर ऑफ डिग्री ऑफ हॉटनेस और कूलनेस. इट इज द मेजर ऑफ हॉटनेस और कूलनेस. फाइन. अब ये जो हीट है ये कौन से चीज के ऊपर डिपेंड करता है? द हीट डिपेंड्स ऑन सर्टेन थिंग्स. And what are the things? The things on which heat depends, it depends upon mass. मास के ऊपर डिपेंड करेगा. मास के साथ साथ द बॉडी का टेम्परेचर, उस बॉडी का टेम्परेचर, द टेम्परेचर ऑफ दैट बॉडी, एंड ऑल्सो द मटेरियल by which it is made. ओके, जिस टाइप के मटेरियल से ये बना जा रहा है वो ऑब्जेक्ट, उसके ऊपर भी द अमाउंट ऑफ हीट विल डिपेंड. एंड द अमाउंट ऑफ टेम्परेचर विल बी डिपेंडेंट ऑन द एवरेज काइनेटिक एनर्जी ऑफ एनी बॉडी. ओके, it depends on depends on kinetic energy average. Ke means kinetic energy average. Kinetic energy average क्या होता है? हम जानते हैं किसी भी ऑब्जेक्ट में molecules present होते हैं, and when we apply heat to that particular object or that particular substance, the molecules present in the object gets energized and they gain some kind of kinetic energy. जो एक एक मॉलिक्यूल है सबका काइनेटिक एनर्जी का अगर एवरेज करें, then we will find the temperature of that particular body. Okay, heat is measured by principle of calorimetry. Heat is measured by principle of calorimetry. ये मेजर होता है प्रिंसिपल ऑफ कैलोरीमेट्री से. प्रिंसिपल ऑफ कैलोरीमेट्री क्या है? वी विल डिस्कस लेटर इन दिस वीडियो. प्रिंसिपल ऑफ calorimetry, and it is, we all know, temperature of any body is measured by the device called thermometer. Okay, the device called thermometer, उससे measure होता है the temperature of any body. Okay, and next up is the units. The units can also be a comparison between these two physical quantities. Units क्या होता है? CGS में heat's unit is calorie. Calorie is the unit of CGS, heat, and in SI its unit is joule. Okay, temperature having CGS units degree Celsius or degree Fahrenheit, and in SI temperature is measured in Kelvin. Okay, these three are basic temperature scales that we all know. There are some other temperature scales also, but which is out of your syllabus currently. Okay, mainly we will discuss Celsius, Fahrenheit and Kelvin scale in this chapter. And one more thing, between these two SI and CGS units of heat there is a relation. There is a relation which is 1 calorie equals to 4.186 joule, approximately 4.2 joule. Okay, this relation is very important. MCQs come depending upon this relation. Okay, 1 calorie equals to 4.2 joule. Okay, so this was a comparison between heat and temperature. Moving on to next topic, which is relation between all the three scales: degree Celsius, degree Fahrenheit and Kelvin. So let us take a look about the temperature ranges of these three scales. Okay, the temperature ranges of these three scales. What are they? This is for degree Celsius, this is for degree Fahrenheit, this is for Kelvin. The upper temperature which can be measured by a temperature scale is called upper fixed point. The highest possible temperature that can be measured by a particular scale is called upper fixed point, and the lowest possible temperature can be measured by this scale is lower fixed point. The difference between upper and lower fixed point is called fundamental interval. Okay, it's called fundamental interval. Let us see what are they. For degree Celsius, the upper fixed point is 100 degrees Celsius. This is fixed. Highest possible temperature can be measured by degree Celsius scale, and lower point is 0 degree. Fundamental interval is 100 degrees Celsius. We all know that. For this it is 32 degree Fahrenheit. Sorry, one sec. This is 212. Upper fixed point is 212 and lower fixed point is 32 degree Fahrenheit. Fundamental interval is 180 degree Fahrenheit. Okay, and for Kelvin scale, this is upper fixed point which is 373 Kelvin only. In Kelvin scale there will be no degree sign. Okay, remind it carefully. In Kelvin scale there is no degree sign. Degree sign नहीं यूज करेंगे. Lower fixed point है 273 Kelvin, and it is having a range of, that is fundamental interval of 100 Kelvin. And there is a relation between these three scales. Okay, there is a relation. What is the relation between these three scales? Which is C by 5 equals to F minus 32 by 9 equals to K minus 273 by 5. This is a general relation between these three temperature scales. Okay, ये हमको कहाँ पे यूजफुल होगा? जहाँ पे प्रॉब्लम्स आएंगे सेल्सियस को फ़ारेनहाइट में कन्वर्ट करने के लिए या फिर फ़ारेनहाइट को केल्विन में. ओके, वहाँ पे हम ये रिलेशन यूज कर सकते हैं. और डायरेक्टली अगर सेल्सियस और केल्विन का एक रिलेशन चाहिए होगा तो उसको हम लिख सकते हैं ऐसे कि सेल्सियस प्लस 273 इक्वल्स टू केल्विन. डिग्री सेल्सियस का जो वैल्यू है उसके साथ सिंपली इफ वी add 273 we will get the value of Kelvin. Okay, is this clear for you? You can take screenshot of this chart. Okay, this is all about the three temperature scales we know. Okay, let's move on to the next topic, which is thermal expansion. Thermal expansion के बारे में हम क्या जानते हैं कि whenever we apply heat on any substance it has a tendency to expand. Okay, it has a tendency to expand. Whenever we apply heat on any substance it has a tendency to expand and its volume will increase. Okay, is it? जब भी हम किसी टेम्परेचर किसी ऑब्जेक्ट के ऊपर हीट अप्लाई करेंगे its volume will increase. But this is normal expansion. This is normal thermal expansion. But what about if we apply heat on any substance and the body contracts? Isn't it abnormal? Yes, this also happens. If we apply heat on ice, it will contract up to the temperature of 4 degrees Celsius. And then after it will start to expand normally like other substances. This abnormal thing is called anomalous expansion of water. Okay, this anomalous expansion of water, इसमें क्या होता है कि if we apply heat on ice, this is ice cube, heat is added, triangle और delta sign से heat को डिनोट किया जाता है. Heat is added, its volume will decrease. It will contract till 4 degrees Celsius, till the temperature 4 degrees Celsius. After that then it will expand. Okay, ये जो चीज है सिर्फ वाटर के केस में नहीं होता, दूसरे और भी कोई एग्जांपल्स है जहां पे ये anomalous expansion can be seen. Another thing like silica below minus 80 degrees Celsius, another thing is silica. Another example is silica which shows anomalous expansion below minus 80 degrees Celsius. One more example is silver iodide, AgI. This is silver iodide. सिल्वर आयोडाइड क्या होता है? ये 80 से 110 डिग्री सेल्सियस तक इट शोज एनोमलस एक्सपेंशन. फ्रॉम 80 डिग्री टू 110 डिग्री सेल्सियस इट शोज एनोमलस एक्सपेंशन. ओके, दिस वाज ऑल अबाउट एनोमलस एक्सपेंशन और एबनॉर्मल एक्सपेंशन विच वी कॉल इन केस ऑफ वाटर, सिल्वर आयोडाइड एंड सिलिका. Okay, let's move on to the amount of heat. Okay, the amount of heat, how can we measure? How can we measure that one object has gained that much heat, or the temperature of that object is raised from this to that? How much heat is required for this to do? We will know that now. So when we want to know what is the amount of heat that is gained or lost by a body, we have to know some quantities which is related to that particular thing. And what are those quantities? We have to look after two main equations to find out the amount of heat gained or lost by a body. So first equation is heat, that is H equals to M into S into delta T. What are the terms? This is mass, M is mass, S is specific heat. I will explain what specific heat is. And delta T is change in temperature. Okay, delta T is simply T2 minus T1. Delta T is nothing but T2 minus T1 means the object is heated to some temperature. It was previously having a different temperature. So पहला temperature और last temperature का जो difference है, that is the thing which should be written under del T. Okay, this is H, this is amount of heat, this is mass of that substance, this is specific heat of that substance, and the temperature change. Another thing is H equals to ml. Now this L is all the two terms are known to you, heat and mass, but L is latent heat. Okay, L is latent heat for any substance. Now what is the difference between latent heat and normal heat? Okay, let me tell you first what is normal heat or sensible heat. Sensible heat is that which creates the temperature change. Okay, when we apply some amount of energy or some amount of heat energy to any substance, what happens? First of all, it starts to energize its kinetic energy. उससे क्या होता है? The temperature of the body rises up, और अगर हम heat किसी से ले लेते हैं, the temperature of the body will fall down. And this temperature which can be measured and which can be felt that it is hot or not, ये जो मेजरमेंट आता है जिस टेम्परेचर से, जिस हीट से, सॉरी, वो हीट को बोलते हैं सेंसिबल हीट. बट लैटेंट हीट इज वी कैनॉट सेंस इट, वी कैनॉट मेजर इट, बट इट इज रिस्पॉन्सिबल फॉर द चेंज इन स्टेट. ओके, व्हेन आइस इज मेल्टिंग, व्हेन वाटर इज इवेपोरेटिंग, दिस इज अ चेंज ऑफ स्टेट. ये जो स्टेट चेंजेस होते हैं, इनमें लैटेंट हीट का इंपॉर्टेंट कंट्रीब्यूशन रहता है. So latent heat is different from sensible heat. Okay, this is the thing. In this equation we have to apply whenever there is a state change. Suppose ice to water, suppose water to vapor. ये सब changes, state changes जिस phases में होंगे, वहाँ पे we have to apply this formula. But when there is a normal temperature change but the state is not changing, then in that case we have to apply this formula. Okay, and now from here we can write S, that is specific heat, equals to H by product of mass and delta T, which is nothing but heat by mass into temperature. Specific heat को define करेंगे तो क्या बोल सकते हैं? That is the amount of heat required. Okay, specific heat of any substance is the amount of heat required for unit mass of a substance to increase its temperature by 1 degree. Let me repeat it once again. To increase any substance's temperature by 1 degree having unit mass, the heat energy required is called specific heat. Okay, and what is its unit? Unit इसका क्या होगा? SI में अगर करें तो unit इसका क्या होता है? जूल पर kg पर केल्विन. जूल पर केजी पर केल्विन. और CGS में कैलोरी पर ग्राम पर डिग्री सेल्सियस. ओके, दिस इज द यूनिट ऑफ स्पेसिफिक हीट. एंड लैटेंट हीट, व्हाट इज द यूनिट ऑफ लैटेंट हीट? CGS में लैटेंट हीट का यूनिट होगा कैलोरी पर ग्राम, एंड इन SI इट विल बी जूल पर केजी. ओके, to convert ice into water we have to apply 80 calories. These are some information which will be helpful for you. And to convert water into vapor we need 537 calorie. Okay, these are the latent heats required for this state changes. 537 calorie, and this can be written as 540 in some books also. Both are okay. दोनों लिखोगे तो दोनों में ही करेक्ट होगा. ठीक है. Our next topic, which is calorimetry. Okay, now what is calorimetry? We have to understand that if we keep two bodies having different temperature in contact, okay, अगर हम दोनों बॉडी को, एक में ज़्यादा टेम्परेचर एक में कम टेम्परेचर है, कॉन्टैक्ट में रख देंगे, उसमें जनरली क्या होता है? हीट विल फ्लो फ्रॉम higher temperature to lower temperature, that is from hotter body to cooler body. Okay, but there is some condition, and this condition is obeyed under the principle of calorimetry. What is calorimetry? Calorimetry is simply the method to know the amount of heat gained or lost by a body, and this study or this phenomena dependent on some kind of principle. Let us know what the principles are. So what is principle of calorimetry? Let me write down. Principle क्या बोल रहा है कि the amount of heat lost by hot body will be equal to the amount of heat gained by cold body. Okay, this is the principle of calorimetry, but there are some conditions. What are they? First condition, the system in which these two hot and cold body are kept within will be closed. The two bodies will be in closed system. What is closed system here? Closed system means no heat comes from outside. Okay, let me write no heat enters. It will be shorter than no heat enters or leaves the system. Okay, the entire closed system in which these two bodies are kept, no heat can come out the atmosphere and no heat from within the system will go out, so that the net temperature of the system remains constant. And one more thing is no chemical change between these two bodies. इन दोनों बॉडी में कोई केमिकल चेंज नहीं हो सकते. They cannot react chemically within them. It will hamper the principle of calorimetry. So one last topic, which is heat transfer. What is heat transfer? Like any other energy, it can be transferred from one place to another, or it can be transferred from one part of any substance to another part of that particular substance. To perform such kind of activity, which is known as heat transfer activity, let us know the classifications of heat transfer. The classifications of heat transfer. Let me write it in a tabular form. Okay, the first one is conduction. Second one is convection. Third one is radiation. Okay, conduction, convection and radiation. Conduction में क्या होता है? In this process, the particles of any hot object starts to vibrate. Okay, and by vibrating this particles, the heat is transferred from one end to another end. One end to another end heat transfer होता है. In conduction process में particles, hot particles अगर vibrate करते हैं, और to keep in touch, ऐसे एक ये मानिए एक रॉड है, इसमें एक particles है which are closely bound. If this particle gains heat, this will automatically gain heat. This will also automatically gain heat. Okay, क्या होता है? तो इसमें particles cannot change their positions. इसमें no movement of particles. Okay, but in case of convection, there is a movement of particles. Movement of particles of that particular body in which heat is applied. In case of radiation, what happens? This is performed in a wave manner. This occurs in a wave manner. Okay, this is performed as a wave manner, radiation. Conduction में क्या होता है? It is a slow process, obviously. It is also a slow process, but it is faster process. Faster process. The third one, medium required In this case also medium required to transfer the heat from one place to another, but in this case no medium is required as such. No medium is required क्योंकि ये एक वेव मोशन में होता है. It needs no medium to propagate the heat energy and hence it is a faster process. Examples का एक example radiation का होगा कि sunlight is coming to earth in the process of radiation. Okay, sunlight is coming to earth in the process of radiation. One more thing is that in case of conduction, it is only happen in solids. It only happens in solids, liquids and gases. और ये radiation क्या होगा? I have just told you, radiation occurs when sun heats earth. और एक example क्या आ गया? In case of room heater. Room heater के case में भी radiation process is used. There is no material medium present to transform heat from this machine to room atmosphere. So in this case also radiation is followed. Okay, these are some comparison between the three types of heat transfer. One is conduction, convection and third one is radiation. Radiation is the fastest process. Okay, so this was all about heat and energy. If you do have some requirement or any queries regarding this particular chapter or on any other particular topic, you can write it in my comment section. I will gladly accept your request, and do not forget to share this video so that your friends can also have their required knowledge. And please don't forget to like and subscribe my channel, which is physics module. There will be lot of videos coming on your way. So stay tuned, stay healthy, stay with physics. Goodbye.